Hey guys, welcome to today's tutorial looking at two-way tables, and for the most part this is pretty straightforward, but the way that they present some of the questions, it can get a little bit tricky and you can make mistakes quite easily, so you've got to be careful. Look, basically two-way tables compare give two different views of the same information. For example, if I look horizontally here, you can see for females, it's comparing them against them walking and not walking. So 37 females walk, 28 females do not walk, and 65 females altogether. If I look at it vertically though, it's comparing how many people walk. So 37 people female walk, 35 males walk, 72 people walk altogether. Now, as I said, the way they present the question can get slightly tricky. They might say, of what fraction of females walk? Which means, well, 37 females are walking and there are 65 females altogether. But they could re-ask that question and say, what fraction of people who walk are female? Well, now you're doing 37 out of 72. Because the first one was saying what fractions of females, the 65 altogether. The next question I said, what fraction of people who walk? So the way they sort of ask that question, you really need to be careful. The second problem with this stuff is the diagnostic test. They can get a little bit confusing. I want to explain that. So diagnostic tests, you go to a doctor, they test you for a disease, and the test comes back positive or the test comes back negative. Now, as you see in the news, all the time you're seeing cases where those tests actually were incorrect, they were false. Obviously some of them are true, and you're going to get most of them will be true, but occasionally those tests come back and they're actually not correct. So what this two-way table does, this tells you whether or not the disease actually is present. So this sort of column here for true and false means that absolutely the disease is present, and they're telling you that. Or they're saying no, absolutely not. The disease is not present. So we kind of know 100% anything up in this column, yes, they've got it, or in this column, no, they don't. And then we can compare that back with the actual test result. So let's say, for example, the test comes back positive and we know that disease is present. Therefore, we call it true positive. The test was correct. Certainly, they came back positive and we know that they actually have got it. But in this case, the test comes back negative. So this little bit here is called false negative, because we know that in this column, this row, should I say, we know that it is present. We know the disease is there, but the test came back as negative. Okay, so it's going to be false. Likewise, if we look at the bottom row in the first column, well, the test came back positive, but we know that the guy doesn't have the disease. Therefore, it's a false positive test. Okay? Because we know he doesn't have it. And then we've got the negative one. It came back negative, and we know that he doesn't have it. Therefore, we call it true negative. Okay? So in terms of the doctor, the doctor wants to have tests coming back as either true positive or true negative, because that means that they tested it correctly. However, if it comes back as positive and they don't have it, which is false, or comes back negative but they have it, that's false. We call those false positives and false negatives. So that's where it gets a little bit confusing, I'm afraid. But the good thing is you don't get too many questions on diagnostic tests, but certainly they can come up. Okay, let's look at a couple of examples here. So the number of laptops sold in the past 2 weeks is shown below. So we've got brand X and brand Y. We've got week 1 and week 2. How many laptops were sold during the 2 weeks? Okay, so we've got here for brand X, we've got 130. And we've got for brand Y, 390. Therefore, if I'm adding those two amounts together, we're getting 520. So it's pretty straightforward. And often they will actually give you the easier questions like this, where you just have to simply fill in the missing values. For B, it says how many brand Y laptops were sold during week 2. Well, obviously that's B, because they haven't filled it. So you can either look at we sold 390 altogether. Week 1 we had 240, so we could do 390 subtract 240, and that's going to give us our correct answer of 150 laptops. Alternatively, you can say, well, in week 2 there was 50 of brand X, there were 200 altogether, therefore there must have been 150. So you can kind of do either way to get the answer to part B. Part C says, what fraction, now this is where I was talking about before, it gets a bit tricky. What fraction of brand X laptops, okay, so that's really important there, of brand X, which means my fraction will be out of brand X, 130. And it says, were sold in week 2. Well, in week 2, we sold 50. So we've got 50 out of 130, which brings us to 5 out of 13. Again, if they ask for a percentage, you just times it by 100. So part D says, what percentage of the sales in week 1, okay, so of the sales in week 1, again, of the sales in week 1, well, that means of the sales in week 1, well, sales in week 1 were 320, so it's going to be out of 320, were brand Y. Okay, so in week 1, brand Y were 240. Okay, and then I can simply put that into my calculator and times it by 100, this is a percentage, to get 75%. So you can see how the wording is really important, and certainly they'll say those things like of brand X or of the sales in week 1. So you need to figure out what part they're looking for. Part E says, what was the probability of selling a brand X laptop during the past 2 weeks? Well, that part, it's asking out of the whole lot, okay, of the whole 2 weeks, what percentage, what probability, what fraction would it be of selling a brand X laptop? Well, out of the whole lot, will be out of that 520. Therefore, how many were brand X? Well, we had 130 of brand X. So if it does ask what fraction or what percentage, you can do it that way. We want the probability, so we're just going to leave it as a fraction, as 1/4, or you could put 25% if you like that one as well. So again, guys, you can see it's actually not too difficult as long as you take your time and just make sure you're putting it over the correct one, because that's probably where you'll you'll fall down upon. All right, so the last one here, we're going to look at a diagnostic test, which people sort of certainly get a little bit tricky with. A new diagnostic test has been developed for determining whether or not a person has a flu virus. The test was given to 400 children at random. The results of the tests are shown below. So, from that first example, we said, and you can see here, that on the left-hand side, so this first column, we know whether or not it is present or absent. Okay, we know. This whole thing is, apologies, this whole thing here is we know it's 100%. So that all there is correct. But the test came back positive and it was present, therefore we could call that true positive. It came back positive, but it was absent, so we call that false positive. Okay, so you can sort of see where I'm going with those last couple of words. But let's just do the questions and see what they're asking us. How many of the children tested had accurate test results? So I'm looking for the test being positive and it's being present, so yes. The test came back negative and it was absent, so that one's true. They're both accurate. Therefore, we have 350 accurate tests out of 400, okay, which is then going to be, actually, so it just says how many were accurate, so I didn't even put over 400, so just 350. B, what fraction of the children who received a negative test? Okay, so these are the children who received negative, so it's going to be out of 220. So what fraction of the children who received a negative test have a flu virus? Well, 200 have the flu virus. So 20 of these tests have the flu virus. So I'm going to put 20 out of 220, which brings back a fraction of 1/11. So again, you can see that these are 20 people who actually had it, came back negative, but again, it's only a very small portion of them. Part C, what percentage of the children without a flu virus, so without a flu virus, so flu virus absent, which is 230 people, I'll put that down there now, had been given a positive test result. Well, okay, out of these 230 kids, 30 kids were given a positive test, which gives us 30 out of 230. I'm going to times that by 100 because it says percent, and I'm going to get approximately 13%, or 13.0%. And D, we've got, what is the probability? So again, decimal, fraction, percentage. What is the probability that a child who received a positive test result has the virus? Okay, well, we've got 150 people here and 20 people here who have the virus. Okay, so we've got 170 people altogether that actually have the virus. And it says, from what probability the child who received a positive test has the flu virus? Well, positive test was 150, because 150 of those people actually received the positive test. We can times that, well, actually we can just put it as a fraction. We can put that as 5/6. So again, that's pretty good odds that, you know, the test is pretty accurate. And then the last one, which is E, what is the probability the diagnostic test will be inaccurate? Okay, so for this question, we want to see how many of these tests were not accurate. Well, in the very first part of the question, we looked to see how many tests came back as accurate, with 350, which means the other two ones, so the 30 and the 20, they're the ones that were inaccurate. So that's got 50 tests that were inaccurate out of the 400 tests altogether, which brings us back as a fraction of 1/8. Again, you can put that in decimal form or percentage form as well. So look, you can probably see those last couple of questions, particularly with the diagnostic tests, they get a little bit challenging. You'll be really careful. Okay, just take your time, have a practice of some of these questions and the questions in the past exams that we've handed out to you. And any problems, please let me know. There's usually 1 or 2 of these in an exam paper, so just be very careful and take your time. Have an awesome day, guys.